Hello and welcome to Hacking State. This is your host, Alex Murshak. With me today is Matt Parlmer. Matt is the founder and CEO of Gen Fab, General Fabrication Company, a
hmm
3D printing, manufacturing, and machine tooling startup. Matt, it's great to have you on the show. Welcome to the show.
Hey, glad to be here.
I'm so glad to finally have you on. You and I'd say we're friends. We're at least acquaintances. We've met a few times, and
Yeah, I've enjoyed all of our conversations thus far. It's fun to get this kind of thing taped.
yeah,
Uh,
yeah.
yeah,
So I'm really glad to have you on because American manufacturing, reindustrialization. I feel like I'm a Midwest kid, and I think you're from
where from?
Chicago as well. Uh, so I've been talking about the need for industrial capacity for a real reindustrialization,
hmm
in my own personal life for like 20 years, right?
Right. Yeah.
And I'm part of a group of people that, millennials in general that sort of saw the aftermath of deindustrialization, especially in those Rust Belt parts of the United States. And so I'm really glad that the tides are finally turning and it's sort of on trend to be talking about American manufacturing again, to be talking about reshoring, industrialization in general. But I wanted to first uh, get your origin story as far as General Fabrication Company, where the idea for this came from and what you were trying to do when you started out.
Yeah. So where do you want me to jump into that? Like, do you want to do my background or
Sure, let's start
the
with your
company?
background and
I'm a
then
software. I'm a software engineer by trade. I worked as a political quant for a few years. I was kind of a rent to CTO after that. Briefly convinced myself that this is a company and a half ago, kind of convinced myself that I was going to go. The serverless sort of thing was beginning to happen, and that was very irksome to me. So I decided I was going to go beat Cloudflare at their own game. As you could probably guess, that didn't work. Yeah, and then COVID came down, and I, like many of us, I looked at what was happening with supply chains and what was happening with sort of the orientation of the larger economy, and thought to myself, "Man, this does not look sustainable. There need to be some new entrants into the world of the physical, because the set of enterprises that we have operating there are not doing their job for a wide range of different reasons. The quip about all good families are the same. All bad families have a different problem. What makes GM terrible and what makes Intel terrible are in many cases different. But um, yeah, I don't know. I was involved in a COVID response project in 2020. We were making N95 masks. We were we ran into two primary problems. Primary problem number one was that was that the feds told us to stop.
okay, well
which
that's a problem.
which was, yeah. I can't talk in too much detail about that because of some of the people who were involved. It got very ugly. There was all sorts of, yeah. I don't know. Um, it was a little bit frustrating to be, not a little bit frustrating, like, uh, to me, a profound indictment of our system of government that, random former Obama administration officials were running around telling people what to do, from not inside the government, and then that having, being taken as sort of statements of administrative fiat. All that aside, problem number one we ran into was government opposition to making some very basic stuff domestically, without paying rents to various different organizations. Then problem number two was that the manufacturing infrastructure for making this like very simple, plastic and melt blown, uh, like plastic housing and melt blown polypropylene product was virtually non-existent. Like we looked into the mask supply chain and kept noticing like, oh wow, even the ones that are made in the United States are like, the headband is stapled on in North Dakota, and then the rest of it is just coming from Shanghai. Like, you look at every corner of this, and it becomes clear that, like personal protective equipment has moved over to Asia, and there's, we literally don't have the machine tooling to replicate that here at any kind of reasonable scale. So I started looking into I couldn't do anything about the political part of the manufacturing shortfall, and I certainly couldn't do anything about the political part of, the FDA and the CDC telling people to, not solve solvable problems. So I thought to myself, all right, I'm going to go insane if I don't find a technical solution to some of these things. That's, I'm an engineer. That's the area where I can contribute. And I started digging into what had been happening in manufacturing while I had been, off, like, in the literal and figurative cloud, writing software for the decade before that. And things had come along in a bunch of different dimensions. Sensors got cheaper. The software side of it got dramatically better. The controls side of it has gotten dramatic, or had at that point back in 2021 had gotten dramatically better. And I started to see the outline of something that eventually became engrossing for me, which is this idea of an actually commercially viable, actually technically viable, like first pass at the von Neumann Constructor in a single company. A factory that can make itself bigger and more sophisticated, using mostly its own tools and processes. Obviously, you have to go call out externally for large number of things initially, but if you can keep shrinking that fraction, what you end up with is a business model that has an inherent capital efficiency advantage over anyone else trying to make physical products. And that has been an incredibly engrossing idea, and we've been working on that for since 21 in different formats. At one point we were selling equipment. We're actually not selling equipment anymore. Turns out that if you have a distinct advantage in making capital equipment, you don't necessarily want to give that away. We may go back to selling printers and robot arms and other things like that down the road, but that will be down the road. Now we're working on advanced electronics manufacturing. That is going quite well. We have we've dug around and found some incredibly compelling new processes that fit well with the type of robots that we're good at making. And we've been rocking and rolling with that over the last year or so.
So you went looking into the state of American manufacturing and machine tooling in particular. And then you found out, oh, there's actually a set of technological advances that no one has been paying attention to because we've all been, up our own rear ends in software.
Not no one. The Chinese have been paying very close attention.
Yeah. Americans who have been making all of their money in the virtual world have neglected the physical world and not realized that you're saying the capacity exists right now in your review to build a factory that is self-improving. Is that correct?
Yeah.
Wow. So that's the thesis.
Concretely, like that is, you can the set of processes you need to do the various different inputs of a piece of manufacturing equipment has shrunk considerably in the last few decades, but in particular the last decade or so. I don't want to get into too much secret sauce, but like a lot of problems are fungible in laser. You can get a lot done with a lot less now, and you can also have much smarter machinery than you did in the past. Controls and power electronics have moved along blazingly fast. Like the EV revolution, the smartphone revolution brought cameras, it made cameras and small low power processors a commodity. To some extent, also batteries. The EV revolution has done the same thing for power electronics, and to a much greater extent for batteries than the smartphones or the laptops did. And the implications of those advancements have not even barely begun to play out in the built environment around us. Any distance between where we are today and where we could be, I consider to be it's one of the biggest opportunities in the history of industrial capitalism. Like if the steam engine was big, the electrification of everything is going to be that much bigger.
Yeah, yeah. So, you did have a few. There are several products up on your site. You've got a 3D printer. There's raw. I don't know about raw, but there's uh, thermoplastics materials inputs, as well as the parts farm, which I think, as far as
We're moving much more in a parts farm direction
yeah,
these
as
days.
far as people's awareness of Gen Fab, I think the parts farm is like the notable thing.
Mm-hmm.
I wanted to ask you a little bit about why you started with 3D printing, whether you're limited to plastics right now, and also get into the core idea behind the parts farm.
Yeah, we started with printing because it was a very, it's like most things need like plastic parts to glue stuff together. 3D printing was the easiest way for us to get from 0% self-replicating to like 5 to 10% self-replicating, and go make all sorts of different parts and all sorts of different configurations in a way that is in a way that is highly flexible. There's a lot of like armchair engineering going on about going on about thermoplastic printing. Most of the people who are yapping about that have no idea what they're talking about. I would refer them to what's happening in Ukraine right now. There are vast fleets of FPV drones and now autonomous munitions that are being manufactured by vast fleets of printers. So yeah, that was kind of we consider that to be the best place to start poking around. We also in the last few years have worked on gosh, you know, prototypes that have gotten to any level of maturity at all, probably like a dozen different small modular robots that implement different processes. Mills of the traditional like spinning bit variety, and then also electrochemical milling. We've done we've done quite a lot with lasers, and are doing way more with lasers now. In fact, that's the primary direction of the company, actually. We have been, we've done a bunch of stuff with like pick and place automation. We've messed around with like lab automation stuff. Yeah, just a wide range of things. So the printers were a great way to kind of stress test a lot of the like control systems that we've made, and the kinematic arrangements that we've played with over the duration of the company. Yeah, I think, and it's a very flexible and useful tool. We still use them every day. Yeah, we I think that the most interesting thing that's come out of the 3D printer, the commodification of the 3D printer from like 2015 till today, has been the larger advancement in other, in that sort of like small modular, like low force process robot.
Mm.
Um, and we're, again, this is just, we're in the very early days of this sort of thing proliferating, but you're starting to see lots of different people do interesting things with, with that kind of like, with that kind of like small gantry, or, sometimes an arm, or, variety of different configurations, that have nothing to do with printing. There's pipetting robots. There are, Opentrons are becoming ubiquitous across biolabs, for example. There's all sorts of different, like,
There's going to be a robotic wet
quality.
lab.
Sorry?
There's going to be robotic wet labs soon.
There are robotic wet labs.
Oh, wow. Okay.
Yeah, there are lots of robotic wet labs. A lot of them are hilariously overpriced,
Yeah. Well, I come
and
from
put
a
together with. Sorry.
I come from a family of chemical engineers, and
Sure.
so I worked in an environmental lab actually in high
Oh,
school,
very
and
cool.
then in college, and so
Very cool.
I've done a lot of pipetting in my day, and a lot of those tasks are extremely repetitive.
Yeah.
When you're preparing samples for analysis for heavy metals, whatever, you're doing the same thing over and over and over and over again.
Yeah.
It's not,
Yep.
it's industrial science, but it's not like you're doing new things each time or discovering something. You're just following
Right.
a, uh, yeah, you're just following an SOP, and getting a robot to do all of that would be really nice.
Indeed. Yeah, and it would make for better science too, right? Like this is I've talked before with people who run like academic labs, who kind of view the grad student as this throwaway resource.
Yeah.
And I really don't think it's a good idea to, take post grads and make them do sloppy pipetting for 6 hours a day, before they go start, analyzing the results of experiments or writing papers or what have you. I don't think that's a good use of a human brain. Particularly when you can buy an Opentrons for like, for like 5 to 7 grand. Um, we actually considered rolling a product out in that space, but ended up deciding not to because of perhaps a little bit of trauma around dealing with FDA and some of the other organizations that regulate all of that. We've done a bunch of our own internal experiments before with that type of machine, but yeah, I don't know. It's weird. Lab automation is odd. It's like it pushes through these. Um, it touches so many different disciplines that that you have to like culturally bring on side to get them to support further automation, and that can be kind of difficult.
Yeah, definitely. So, in terms of what it sounds like, Gen Fab has done a lot of experimentation with
Mhm.
different product lines and approaches to things. Are you are all of these like completely vertically integrated in the sense that Gen Fab does the design, the hardware, the software, the entire thing end to end?
Yeah, we pull in
Okay.
we pull in a fair amount of open source stuff, but yeah, we write our own software. We design our own control electronics. We don't make our own motors yet, but that's on the horizon. We don't make our own connectors yet, but that also is on the horizon. We have a bunch of different internal tooling for making a variety of different things. Yeah, we are. A lot of organizations will like vertically integrate around materials or other things like that. We like to vertically integrate around production equipment and around the design process, and I think that gives us a uniquely nimble position among industrial companies. There are not many companies that have even attempted that. There are a few companies where that sort of process has grown up organically. One company that I have immense respect for, who I think did this accidentally but did it really well, is Epson. they with terrible, with the kind of terrible access to capital that you have in Japan, have managed to go vertically integrate a bunch of different production systems. From they started as a watchmaker and built themselves into this dominant player in several projectors, timing crystals, all sorts of different like uh, lab type robots and like precision assembly robots. I think they're the world's largest supplier of SCARA arms, for example. They do in my opinion, the sexiest commercially available 6-DoF arm, and hold pretty strong market share in those segments. Yeah, and all of this developed from them doing this I think organically, because they were in post-war Japan and kind of had to make do with what they
Right.
had. They did this dog fooding process where where they're like, all right, well, we need to make money somehow, and we have this set of capabilities, and we have a pretty smart engineering staff. What can we do to make our own production equipment with our production equipment? What can we do to take the things that we've productized and roll them back into production? And it turns out if you make very precise motors for like for a little like quartz watch, you can also make the very precise motors that move a printer head around. It turns out that if you can make the timing crystals, oscillators and what have you, you also have most of the infrastructure to make the piezoelectric components that go into modern inkjet printers, right? And they have this organization that kind of they organically developed this dog fooding. I think that with access to American capital markets and doing that process intentionally, you can go that much further and that much faster. So yeah, that's kind of our internal organizational model. We develop a capability. We figure out how that capability can help us make more of our own production systems. Is this multiplicative? Does this give us some sort of advantage in building large amounts of equipment down the road? And then we figure out how to go monetize that. In the past, that's been sales of equipment. We are kind of getting out of that business. We will still do some of it, but going forward, it's going to be mostly building and running our own factories that operate with the kind of efficiency that you can only get from heavy automation, like as close to lights out as possible, and that can be built with this compounding capital efficiency advantage that we have from having this at this point fairly sizable stock of internal IP and the process that is that seems to work quite well.
Yeah. Talk to me about the parts farm. What is it? Why do I want one?
Uh,
I can get one in my living room, right?
for
Like I
whatever,
can.
yeah, I wouldn't recommend that. If you can take a like heavy industrial process and factor it out into a bunch of light industrial processes, or parallelize it into a bunch of like lighter tools, it's generally a good idea to do so. The comparator that I often throw out is solar panels, right? Like a solar panel can be installed in a very small chunk. It can be plugged into whatever space you have. You can tile over, however much land you have with solar panels. There's no, you don't need to do a big concrete pour. You don't need to do a bunch of other things like that. I think of manufacturing cells in that way. Like, if you can get it really small, if you can use a low force process that allows you to get it really small, you can go tile over whatever space, and you don't need to do a lot of the sorts of things that come along with installing multi-ton pieces of machinery, and that's why that's why you see the growth rate in solar panels is considerably more impressive than the growth rate even in gas turbines. There are physics based reasons for that.
Mm.
I see this also playing out in the manufacturing space. The physics are the same. You want a small composable module. You want to be able to buy more granular units of capacity than one huge tool. That gives you a much lower risk way of doing business. It gives you a much more flexible way of doing business, and that's why we see these things getting deployed all over the place. Virtually every like company that touches hardware nowadays and does any prototyping has at least a few printers. Many of them are starting to build out parts farms. You're starting to see service bureaus pop up here as well. Yeah, it's and it's starting to proliferate into other process categories as well. We're starting to see a lot of the lab automation stuff in particular. Instead of using one huge cell, you can go factor out your operations into a bunch of different stages in small cells. Once again, that ends up being lower barrier to entry in terms of capital outlay, and it's less of a problem if one thing breaks. Yeah,
What are some
that is in a nutshell the argument for the parts farm.
yeah.
Do heavy industry by composing lots and lots of medium to light industry.
Yeah, so I want to talk to you a little bit about what are the trade-offs of this composability and this modularity as opposed to traditional, especially American manufacturing, which has been around, large scale build outs, lots of CapEx expenditure,
Mm-hmm.
right? You buy a whatever $50 million machine or whatever, and then it just sits there, right? And it doesn't
Yeah.
move. And so if you make the wrong design decisions early in the process, you've now got a big problem that you have to like work around until you can
Right.
rebuild your factory in 20 years. And American manufacturers actually learned a lot from. I'm glad you mentioned that Japanese manufacturer because American manufacturers ended up
Excellent.
learning a
Yeah.
lot from Japanese manufacturers as a result of the fact that they had to build for a much smaller economy with a much shallower pool of capital,
Yeah.
especially
Yeah.
post World War II. And so that informed a lot of Japanese manufacturing. And it sounds to me like you're influenced by that school of thought as well.
Yeah. So what is your
Oh, I
question?
just wanted to ask you if you wanted to elaborate on the trade-offs here between these two different paradigms.
Uh,
So I'm not sure. I think there are limits, right, to
Yeah,
what you
yeah,
can
yeah,
do with
right, right. Like,
modularity and composability.
you can't have a mini foundry.
Right.
Right.
Yeah.
That's kind of difficult. You can't have yeah, they're just like, chemical processes often make sense to do in bulk. This doesn't apply to everything, but it does apply to way more things than you would think.
Mm.
And when it comes to if it were true that heavy metal was the way to do absolutely everything, then absolutely everything would be stamped on these like giga presses, right? That isn't the case. We have a whole sector of precision machining, and probably more parts are made in in that very general tool that doesn't have marginal tooling costs every time you want to switch to something new. Your CNC bit is the same from part to part, whether you're making a jet engine component or like a fixture for a medical device. So yeah, like potentially unsatisfying answer is that these are, there are like there's an engineering trade to be thought through at every level of this. And when you're approaching the problem, you do kind of have to go reason through it, with a level of rigor that unfortunately is not very common in in contemporary business planning.
Mm.
A lot of people like to go buy the most expensive machine tool because it is a it has some sort of perceived value over the significantly less expensive but equivalent capability Chinese product in many cases. um there's a lot of cargo culting, a lot of deferring of risk to the vendor. There's a bunch of other bad behaviors that people engage in, and that distorts the assessment when someone is going to go install a bunch of equipment. Kind of a hard lesson that we've had to learn is that oftentimes you cannot talk someone into the right format of tool installation or selection. And that's part of why we're now selling less equipment. We know better how to do first principles analysis of like factory layout, tool selection, and ongoing operations than a lot of people who we would have liked to be our customers.
Yeah.
And that was a bit of a bitter pill to swallow over the
What
last few years, but
what are
that
the
has informed our direction.
what do you think are the blockers there? Are they just internal
It's
politics?
it's a million different things. I mean, start with the the personnel issue, right? Like
Hmm.
the software business, and to a lesser extent, but an untrivial one, the aerospace and semiconductor businesses have drained competence out of every other industry,
Yeah.
to an extent that I think most people don't realize. Um, the MBAification of things, which is a separate problem. So the first thing is more of an issue with like engineering competence. God bless them. Ford's employees are not, they're not sending their best, right? uh, your top tier University of Michigan graduate is not going to go work at Ford Motor. They're going to go work at somewhere out in California or Texas or where have you.
Or New York.
um, yeah, so problem number one, engineer brain drain. Problem number two, MBAification. There are a lot of people who make golf course oriented business plan decisions. This is management is not this fungible thing. You cannot move it from domain to domain, and be you know have it be consistently helpful. I think a lot of people are familiar with that problem, so I won't belabor that point. And then I think also the there's too much of coziness between academia and industry. A lot of times, academics will go plug themselves into, in particular, some area of advanced industry, and shape it in their image, and things start to lose the urgency that one would see in a company that is very motivated to go make money, and start to take on the character of a professor who's trying to get his name on some patents and some papers and then collect royalties.
Yeah.
And that is that is also a sickness in American industry that we have to go fight against.
So where is the focus of Gen Fab right now, uh, early 2026?
Precision electronics production at large scale.
Mm.
Yeah, we're going to build a plant probably in the Bay Area. It is going to be able to turn around very complex electronics assemblies in very short periods of time at a considerably lower cost than you would get for any other for any other version of this sort of service. We right now, one of the most acute problems in in developing any product is that if you go to like Sierra Circuits or what have you, they're more than happy to get you, 6 boards in 2 weeks for 10 grand, but that there are only a few companies that do even that, and yeah, we're gonna come in and I think eat a very large chunk of that market because we can do that same sort of board, and we'll be able to do at scale that same sort of board in a week, and for I don't want to throw out price points, but like much less than 10 grand, right? And still
Yeah.
be making extremely healthy margins. So yeah, our plant will be doing quick turn electronics. It'll be doing certain types of initially mostly in like invite or close relationship projects for people who need stuff for data centers and for defense projects, and then it will be doing during the slack time, instead of backfilling with a bunch of low margin like garage door openers or what have you. We're going to be making equipment for for subsequent facilities, and
Mm.
starting to lean in really hard to the capex advantage. Right now, we can make between 5 and 10% of any given tool once we have Fab Zero switched on, which will be a very capable pilot facility, but still a pilot facility. Will be making probably closer to like 30%, 30 to 40% of of our equipment in house, and then that fraction will just yeah that will get even better. Every time we open a new facility or scale an existing one. Electronics is neat because there are a bunch of different subdomains where where the primary where the primary component of cost of the thing that you're holding in your hand at the end of the day is the depreciation of the capital equipment involved. If we have a serious advantage in capital equipment for like precision packaging and assembly, or for all sorts of different like aligning laser diodes or what have you, where microns and nanometers matter, and we are particularly good at making really precise small modular robots that can do that kind of thing. We can make an awful lot of money. So yeah, that is the current primary effort. We will we still get approached pretty regularly about stuff that people can use in their garage or their basement,
Mhm.
and I still find that area interesting. We will probably take a swing at the Bamboo Labs printers at some point in the next 18 months. Something that like right now our price points are definitely in the like in the professional tool range, up a couple grand per machine. Once we have once we're hitting like 60 to 70% internal production for a tool like that, then it's probably going to make sense for us to go package together a bunch of different small products like that and get those into people's hands.
Yeah, I
And
wanted.
frankly, at that point, that'll probably be justifiable as a marketing expense for the larger scale, like manufacturing hyperscaler
Yeah,
type
yeah.
operations that we're going to be standing up. Just because when someone goes and runs a part on one of those machines, if they want to go, then subsequently order 100 or 1,000 of them, there'll be a button in the interface to do that.
Yeah, I wanted to ask you on your attitude towards this, I guess, trend in just-in-time manufacturing and
Mhm.
customization. The firm that's coming to mind mo right now is like Send Cut Send, right?
Yeah, yeah, they're great.
And yeah,
Yeah, they're
and so
fantastic.
so you are interested in exploring that model sort of for the hobbyist uh creators as well. Because the thing
And
is,
well, so we certainly wouldn't go into the businesses that Send is going into because we have a different focus and we work with a different type of machine. That type of large scale subtractive machining is pretty well done by that, and there's some process technology, there's some process technology advancement that needs to happen before we can go make electrochemical mills that have equivalent capability on parts that are that are sizable. It's there, like electrochemical and photochemical machining is there for like very small stuff, and like optical machining with lasers is improving very quickly, but the markets for that are not as not huge yet. We'll probably be doing stuff with those processes for internal use well before we release we release a service, and certainly well before we have a machine that you can buy and throw in your basement. Um, yeah, but that like easily configurable software defined uh, parts on demand business is a very good one to be in if your operations are really solid. If your operations suck, that that's kind of bad. Like ask a lot of the people who've kind of gotten themselves into the the Proto Labs network, or Isometry, or some of these other organizations. Things are not, things are not great in there. If you have if you have a shop that isn't, that isn't, that is not run by software, then it's kind of hard to plug yourself into that, and into that kind of that kind of like customer facing system and perform really well. But if you do that, you have a ton of you have a ton of value to add. Yeah, Send Cut Send, fantastic. RMFG in Texas, Kenneth's company, also fantastic company in the in the metal assembly space. Oshkosh in Utah. I've walked through their facility before, and they do an absolutely terrific job of having custom software on literally everything. It's incredible, like all the way down to the shipping station. They have software in many cases written by one of their co-founders, sitting on sitting on a laptop with a scanner attached to it. It's fantastic. So yeah, that style of that style of like parts on demand business is a very good one. Where we would differ from that in the long run is we're going to have operations that um, all of those companies are buying their equipment, and if we don't have to do that for some large fraction of our equipment, we have scale advantages that allow us to compete, not just with like small batch quick turn stuff, but with, like in the area that we're aiming towards, electronics manufacturers at the largest scale. We have we have a path to China beating China unit economics, and
wow.
I don't think most on-demand businesses can, on-demand parts businesses can say that. So yeah, like that's sort of the scale that we're, that we're aiming for. Like we probably won't get get captured in any particular niche just because setting our business up that way would be not taking full advantage of the capabilities that we are developing and will continue to develop at an accelerating rate.
Yeah, yeah. So, what's really cool about this is that, this kind of business that you're creating, that you've created,
Sorry.
this kind of business that you're creating
Yeah.
is it's all about solving, like you're tweaking all these little things here and there, like turning little knobs and dials, and
Mm-hmm.
basically just you're building this smooth machine where you're reducing all the friction.
It's not very smooth.
Well,
Sitting inside, sitting
this
there,
is
hopefully it looks
this is
relatively
my
smooth from the outside,
idealized.
particularly as we scale.
Yeah,
Sitting
yeah.
inside, it's not smooth.
So
But
I've played Factorio, and
yes, yes,
and it's an enjoyable game, but
very enjoyable game. Yeah.
it does teach you in a very low risk environment what are all the problems when you think that you're going to automate something and you think
Yeah.
it's going to run smoothly with all these material inputs and production inputs and different rates and
Hmm.
electricity usage and water usage and all of that stuff. You learn a lot of lessons along the way. Most of those lessons are that you are a complete moron and don't know what you're doing. And I can imagine that that's basically your life now. With
Yeah, for the last few years, yeah, absolutely. Like
this real life Factorio.
kind of, yeah. I actually never touched Factorio until like 2 years ago, which was well into this effort. And it's a really good thing that I didn't because it would have been, it would have been distracting at critical times.
Yeah.
Um, yeah, really, really fun game. Yeah, to some extent, we are doing Factorio IRL. I have joked about this in the past. The real life is considerably less forgiving than Factorio. Your equipment is not perfectly recyclable, and it certainly doesn't fit in your backpack. No matter how small and modular you make it. There are a lot of other issues with that. But one of the nice things is that in Factorio, for the most part, there are multiplayer games that people will play in that, but for the most part, it's just it's just you. It's nice to be able to work on this with other people. Um, I would also say that God, how else does this differ from Factorio? Um, in Factorio, you don't have to make money.
Hmm.
That is that makes it easier. That makes Factorio easier in some ways, but also harder in some ways because in real life you can actually just go solve problems with money. And as I've gotten better at fundraising over the years, starting from a very humble position, if I, to be entirely honest, I have found that I've found that you can actually just throw money at some problems. That is not our default orientation, but there is no pay to win mode in Factorio, and there are some pay to win modes in certain elements of business, lawyers or what have you.
Yeah.
Yeah, there are no lawyers in Factorio. That's
Right. Right.
another thing. Yeah, that is a major advantage that Factorio has over real life. No lawyers.
Yeah. These
Uh,
are constraints that people aren't taking into consideration.
yeah. Maybe someone needs to make the lawyers mod for Factorio.
Yeah. Right. Right. Sorry, you can't
What
build
are the
that. There's a
what are the bugs
lawsuit
crawling
pending.
up to your thing, smacks a subpoena on your on your
Yeah.
gate, rolls away.
Right. Right. You've been fighting with the power company again.
Right. Yeah.
So uh, I think now would be a good time to maybe transition to kind of the sky high view of things, right? You're
Sure.
working in this space. You're still, I would say, a newcomer in a very old industry,
Yeah.
and and startup world is very different than these sort of legacy manufacturers that existed before.
Hmm.
Right now, there's a lot of hype around American reindustrialization. We're just gonna, you can do things, et cetera, et cetera. Um, what is,
Can you do things? That's a
yeah,
really good
yeah,
question.
apparently, you could just do things. So, what is your current take on the state of American manufacturing? How optimistic are you? where where do you see trouble areas or places where people are perhaps spewing a lot of positive rhetoric, but it's not really
Mhm.
backed up yet by actual capacity?
Have you ever read the Californian ideology? Is this like lefty paper from a while ago?
I
Yeah,
don't.
they're like tying together Newt Gingrich and Ayn Rand and the hippies and all this other stuff. It's worth reading just for one quote that, from there, which is that well, to paraphrase, America doesn't have an industrial policy; it has a defense policy.
Right, right.
And it runs all of its industrial policy through defense policy.
Hmm.
This is a really, really, really annoying thing about the American system. We have this we have this attitude towards the defense industrial base that I think is very, very wrong. Like, the arsenal of democracy that won World War II was not making airplanes or tanks when it was being installed initially. It was making Model Ts. It was making, it was making rail cars. It was making skyscrapers. There was a profit making civilian reason to put in that infrastructure. And a lot of the reindustrialization rhetoric right now is looking at the like object level problem of the American Missile magazine and saying like, okay, I need to go work specifically on scaling missile production. That is a noble impulse, and we do need more and better people working on our weapons, on our various different beleaguered weapon systems programs. But in order to actually reach scale that matters in a peer level sustained conflict, we need to have the civilian production capacity for those weapon systems to scale into, and that is lacking. Like, there are basically no domestic electronic CMs of note when you contract manufacturers of note when you compare to what the Chinese have. There are basically no domestic. I'm going to get myself in trouble here. There are basically no domestic car companies that are being run well, including the one that everyone likes. Right now, I think their factory saturation rate is like 60%. That's a big head scratcher. This company is also ordering motors for its robot from China. They make a car. They make a car that runs on electric motors, and they're
Yep.
ordering motors from a third party supplier. That's a real head scratcher. Uh, yeah, I don't know. Like, there is a so the civilian industry is even more neglected, I think, than the defense industrial base. And right now, people are, they're like, okay, well, we let's go build a TSMC fab so that we have, whatever the leading edge node is, like one of them, like
Yeah.
one fab or two fabs in Arizona, so that we can, so that we can make, like autonomy systems for for weapons in the event of a war. And they're not looking at it and saying, oh well, what we actually need here is a full scale, like multiple full scale leading edge logic semiconductor companies in the United States serving civilian demand, like, making money off of this massive data center boom that we have.
Yeah.
Props to Intel, by the way, for, Intel is a stupendously badly run company um, that employs a ton of incredibly talented people, and then uses their capabilities maybe not in the most thoughtful ways, but at least they, there is and they're to be commended for this. Their senior management at least has enough of a backbone to have maintained the domestic factories for long enough for long enough that Congress finally woke up and gave them money to continue doing that. AMD should be doing the same thing. AMD should have 5 or 6 domestic leading edge fabs. Texas Instruments is actually doing a good job. They're the best of those companies. But American civilian industry is lagging. We need to be able to lead global markets in a bunch of different high value categories in order to have anything worth defending, let alone be able to actually, let alone actually be able to, maintain the global Anglo naval hegemony that has been so productive and fruitful.
Yeah, we're still we're still a maritime empire. Um,
Yeah,
so I,
Thalassocracy and its discontents.
I like this point. It actually is complementary to something that Palmer Luckey came out with recently,
Hmm.
where he was talking about, all the weapon systems that they're building. One of the requirements is that they have to be able to be reproduced in civilian manufacturing commercial facilities, right? They can't be, oh, we built a special
Hmm.
machine that only builds this part and no one
Yeah.
else knows how to do it.
Yeah. Yeah.
Um, but the complement to that is what you said, which is like, well, you actually have to have that civilian commercial
Right.
capacity to begin with.
Exactly. Yeah.
Um,
Anduril should, totally unironically, Anduril should get into VR headsets.
I
If
wonder if anyone at Anduril has considered that before.
anyone at Anduril is watching this, guys, do a fucking VR headset, please. Like, that is the best revenge product ever. You don't need to sell it to to the worst customer in the world, who is your only current customer right now. Like, please just go do that and saturate all of the production lines that you have and build more of them, so that when we do actually go to the mattresses with the Chinese, you have the ability to make a non-negligible number of missiles like
Yeah.
that is, yeah. I don't know. More companies should do that. More defense companies should go do that sort of thing. Like, if you're developing some sort of advanced manufacturing capability or automated manufacturing capability, and it's just sitting there waiting for the government to go buy a bunch of something, then you should maybe think about your business model a little bit.
Yeah, I mean, so I'm here in Austin, Texas, and we have there's uh, a VC slash accelerator in town people know of called the Capital Factory. And they've
Sure.
got a dual use innovation center. They're very well connected to the defense space. There's a lot of defense tech actually
Sure.
here. And that is ostensibly the purpose of wanting to develop dual use things is like, okay, but you need to find a viable pathway for this business in the market. You can't
Right.
just have this one multi-million-dollar contractor
Yeah.
who you just sort of attach onto like a barnacle.
Right. Yeah.
So
We've avoided doing, even though one of the main motivations that I personally have around doing this work is the security of the American way of life. We have not pursued defense grants. We have not pursued CIBR. We have not pursued any of that stuff, and probably won't for quite some time, just because of how it tends to pull you into different configurations of your business that are not very good. It's not entirely the company's fault that that this system exists. Like, the federal government does kind of drag people in the direction of, well, frankly, becoming an acquisition target for for a
yeah,
company.
yeah, it creates a distortion
Yeah,
in the economy, and
big time.
it's an easy way to access capital, especially if you don't have existing networks and you don't know how to raise.
Yeah,
It's a lot easier to go apply for a government grant or whatever.
yeah,
than to try to get some capitalists to give you some money in some cases. So I first learned about the deep problem in American manufacturing infrastructure when I read the Bismarck analysis post on machine tooling some years ago.
Yeah, Ben's machine tooling paper. Yes.
Yeah,
I
yeah.
That has been in the appendix of our fundraising materials since the very beginning, actually. That is a delightfully good little chunk of little chunk of analysis. Um yeah.
So I wanted to, I guess, use this as an opportunity to move into this next question, which is like, how much of the so it seems to me like we're like way behind, like
Yeah.
we're like in a hole basically,
Yeah.
as far as readiness, as far as industrial capacity, never mind defense, just building our own stuff for our own domestic markets.
Yeah.
We basically can't do, um, let alone like wartime full scale, you know, whatever transition to military and industrial. Um, what are the but the thing about deindustrialization is that there were policy decisions that were made uh, both in terms of at the individual firm levels as well as in terms of U.S. trade and other things like that, as well as U.S. government investments and so forth. So I wanted to ask you, are there any policy barriers or directions that people are moving in that you think are either positive or negative in terms of buttressing or harming this I'll call it an intention towards reindustrialization?
At the highest level, I think that the current administration is way too focused on tariffs and way and puts way too little emphasis on direct investment. Whether it is equity purchases, which is great. It is fantastic that they're finally doing this. Whether it is underwriting loans, loan programs office was already doing this during the from the Obama years until very recently. Now it's all kind of caught up in some Department of Energy, like turf squabbling between various different people in the Trump administration right now. They should really figure their shit out and start deploying that money again, and into solar. In
Yeah.
addition, like nuclear reactors 5 years from now, awesome, hell yeah, spend as much money as you want on it. That's great, but please also, a couple $100 billion into solar like now today would be great. Um, yeah, way too much emphasis on making inputs more expensive, and way too little emphasis on making outputs globally marketable. We will make this country a very small and poor place if we decide that we are going to be a closed economic system. That is not a great idea for global maritime power to, you should not structure your economy that way if if you have as a totally viable alternative, this massive global market that you can go plug into, to sell your wares. In order to do that, you actually have to make wares, and in order to do that, you need to make things that people want, and people, and ideally, that's more than fucking soybeans and exotic
And
financial
SaaS
products.
apps? What about SaaS apps? We make lots of SaaS
Well,
apps.
no, everyone's banned our SaaS apps. Like they
Oh,
don't want, yeah, like we're very rapidly reaching the point where no country on earth wants American software companies around.
yeah.
And given the behavior of American software companies, can you really blame them? Like, yeah, I don't think that I don't think that we should really hang our hats on exporting, on exporting that kind of stuff. Um, you know, I hope that people within the administration do understand this. I have heard some encouraging things from people I have also heard some discouraging things from people. There are some folks who really do think that if you just tariff China harder, which of course the president won't do anyway because he doesn't want the stock market to blow up and therefore will allow Nvidia to sell however much they want. If you tariff foreign countries hard enough, magically the American industrial base will bloom. That is not going to happen. Tariffs have no relationship to the creditworthiness of American industrial enterprises. Tariffs have no relationship to, I don't know. I don't want to give any credit at all to economists. That is a snake oil profession full of schmucks who are, who are most of the time lying, even when they don't know it. But one thing that economics was, that mainstream economics is right about is that if you make trade harder, there will be less of it, and there is such a thing as needs to trade. And that is something that we forget at our peril. A couple things that have been encouraging. The few things that have been encouraging have almost all been direct investments. The MP Materials deal was great. Like having domestic critical mineral availability is extremely important. The Intel deal was great, though I would like them to throw money at a bunch of other people. James Prout at Substrate has a really cool thing going, and they should like quadruple his funding. The Yeah, there's a bunch of other areas where they're starting to flirt with throwing more money in. The nuclear stuff, they do seem to have a really, like they seem to be taken by this, but by the idea of nuclear power, which is excellent. This is fantastic.
Great.
This move is finally taken off. I worry that the return horizon for those investments is going to end up disappointing a lot of people, but it's good that we're making them anyway. I don't know. Someone needs to go figure out how to pitch solar to Donald Trump. I was on the Gulf Coast, visiting girlfriend's family over Christmas break, and I saw a house with like a massive like 9 foot by 5 foot Trump 2028 sign, bumper stickers all over the back of the car, and the entire roof covered in photovoltaics. There's a lane here.
Right.
There's a lane here. This can be done. Like we just have to do it. Someone has to make this pitch.
Maybe that guy.
Sorry?
I said maybe that guy.
I need to go fly back there. I need to go talk to that guy. And need to be like, hi, please hop in an airplane with me. Go to DC. We're going to talk to your congressman. We're going to talk to some people in the administration. Solar is not fake and gay. Solar is based. Like,
yeah, right.
Let's move this along. So I don't know. There's the potential for some encouraging things there, but I don't know. We'll see. There's they seem to be starting to get the message that that like grid infrastructure needs to be improved. That is a bit encouraging, though I do wish they would just kind of make a sweeping declaration like they have in a lot of other areas and just be like, the old way of doing things is done. Federal right-of-way preemption is the way we're doing things. Fuck your local objections. We're building trunk line like that. That would be very encouraging. They haven't done that yet, but they're totally capable of doing it. And it's one executive order away. Let the lawsuits work themselves out later. Like at least we'll put the infrastructure in. What else? The arm twisting of Jamie Dimon into lending money to American companies that do things seems to be underway. That is encouraging. More of that sort of, like American banks are effectively state managed institutions already. A lot of my libertarian friends, get they cringe really hard when they see, things like the president sent a Truth Social like banger about how, banks need to start lending to, lending to these enterprises. If they don't do it, they're going to be sorry.
Yeah, yeah.
I'm totally fine with these, basically at this point, like, we are already on, let's be real, we are on the hook for Bank of America and Goldman and,
Oh
all
yeah. Oh
of these
yeah.
downside risks. We all know this. They should be taking directives from elected officials in certain areas when there is an enormous public good on the other side.
Well,
Um,
I think just to riff off this a little bit,
yeah,
when you said, okay, going you know, going like armadillo mode as a maritime empire doesn't make sense, obviously.
right. Yeah,
Um, but I think one of the things that causes people hesitation when you start talking about, okay, well, the tariffs are bad, they're increasing the inputs of raw materials, et cetera, is like, well, we've seen what happened during the age of globalization, right? Which was the transformation of the economy into a purely service-based economy where
yeah.
everything is about either financialization or things with zero marginal costs of replication, i.e. software.
Does
Um,
software have zero marginal cost of replication? Because man, I'm looking at a lot of the financial statements of these. I had a tweet thread a little while ago about Texas Instruments filings versus Figma's filings. I'm about to talk a bunch of shit here.
Oh,
So
I've seen this tweet. I know what you're about to get into.
yeah, okay. So
Well,
profit per employee at
depends
Figma
on
is
how well you run your software company.
right. Yeah, yeah. So I don't know. I'm sorry I interrupted you, but like it is not entirely clear to me how software companies don't have even way better gross margins, given that they're able to take most of the software engineers who are like, they're working on the production system all day and lump them under R&D and keep them out of that gross margin calc. Like that's just an accounting trick. That's not a fundamental thing of business. If you look at the operating margins of these businesses, I mean, they're pretty, like even less Figma's massive stock compensation. They're pretty comparable. If not Texas Instruments being a little bit better, with Texas Instruments, which spends a third of its revenue every year on new capex.
Mhm. So
Anyway,
to
sorry.
finish my question though,
I
it's
apologize. Yeah.
how do you prevent this distortion where basically all of the money flows, especially because of the fact that we're under this fiat system that, basically it's first come, first serve as far as
Mhm.
capital when the money is printed. Therefore, the people with the easiest access to capital markets, i.e., banks, institutional investors,
Mhm.
uh, you know, unicorn startups, et cetera, basically they have agglomeration effects, and those tend to be also only on the coasts. How do you actually start? Like, it seems to me like the first step to reindustrialization per se, whether it's civilian or otherwise, is you have to actually make sure that the people that are doing real hard things, which are going to have smaller margins than purely financial plays or purely software plays,
Mhm.
uh, actually have access to capital.
Yeah. You can do a number of different things. Like you can make the tax treatment of capital expenditure significantly more favorable. There are a bunch of different levers you can pull on that. Not a tax lawyer, so I don't want to get over my skis there. But yeah, there's some like the what is the I forget the name of the actual provision in the CHIPS Act for this, but there are advanced manufacturing production credits that you can claim, which are good. We should expand the scope of that sort of like CHIPS Act tax exemption. We should make it possible to write off a lot of capital equipment installation. Being overly broad with that is better than our current system.
Yeah.
I get that I get that people are worried about overproduction, but being worried about overproduction in an environment where the Chinese can just swamp us in essentially every industrial category is not, that is dumb. Like we need to actually be able to do, advanced manufacturing at high volume. Um, so yeah, better tax treatment of capex. I think tighter rules on scammy financial nonsense, and also, the banks, like if you have banking institutions, right, basically arms of the government, um, if they are, if we are eating downside risk for JP Morgan, JP Morgan should be eating downside risk for solar farms and for factories. Like that is how that trade should look. Right now, there is no trade. It is a pure giveaway. People will object that this makes our Chinese, or sorry, this people will object that this makes our banking system look a little bit more Chinese. My rejoinder to that would be, is that bad? They seem to be installing a lot of productive capacity, and and the Chinese financial crisis that everyone keeps predicting every, like I think the Wall Street Journal has predicted like 8 of the
Any day
last
now.
10 financial crises in
Yeah.
China. Like it's yeah, like maybe learning some things from a society that actually builds stuff, at least at that level would be a good idea. um yeah, I don't know. There are a few other things that we can do to make sure that money flows to, the money flows to productive activities. But I think the big low hanging fruit ones are, our tax policy, and then and then some arm twisting in the financial institutions. And then I would also say that while those would help a lot, the ultimate problem is cultural. Like we have a culture among American elites that is, very unserious about a lot of things that it should be very serious about. I don't know.
Well,
That's a common refrain that a lot of people, have. I think that at some point we need to stop complaining about it and start insisting. It's just like, no, you will not do stupid shit. Like, if you do stupid shit, we will freak out and have a temper tantrum of our own.
yeah, we will
Like,
take away your money. We will put you in
yeah,
jail. These kinds of things.
right, yes, yeah, yeah, yeah,
Yeah.
exactly, exactly. We will take away your money. We will put you in jail, and if we get really mad, maybe people stop getting invited to parties. You know,
Yeah, you might
like
not be able to go to the fun events. That's what will really get him.
you
So
would have you. Oh my God, maybe you do have an idea. That is social sanction
no, of
in
course.
DC
Of
is
course.
so potent. It's absurd. Like the yeah, I don't know. We could talk
Yeah.
about DC a lot, but I'd
I,
rather
I, I
not.
try not to do a lot of moralizing. But I this is something that the older I get, the more I see it
Yeah,
and the more disgusted by it I am. But so this does get me to the next point when you mentioned culture, which is I think there's a real dearth of like there is a real dearth of skilled people in the right areas. It's
yeah,
not that Americans aren't skilled or aren't intelligent enough or that we don't have enough smart people.
yeah.
It's that they're all doing the wrong things, or they're doing things that are not in this domain.
Hmm.
Uh, you can argue whether they're right or wrong, but for myself, for example, and you have a similar trajectory. Like I come from the software world. The
Yeah,
reason I'm in the software world is basically because of, I mean, both because I like inherently the idea of automating things and working with computers, and I've always been interested in that stuff. But I also don't have a hardcore engineering background.
yeah,
And so if I'm going to work in tech, it's the lowest barrier to entry thing for the last
sure,
15 years. Anyone can get into it if you're willing to basically learn how to code.
right.
Now I'm a little bit more advanced in my career and I'm doing a lot more technically sophisticated stuff and I've got some experience under my belt. I can actually start to dedicate some time to learning some other skills. But if I wanted to move into a hard tech space, it would basically be a total reskilling from what I know about software. Some of my software skills would apply, you know.
Most of them would. It,
Okay.
I technical problem solving is structurally invariant across fields.
Okay.
That you're like the same like sectors of your brain are firing in the same order when you're looping through like a a problem involving a heat sink as when you're debugging a C binary or something like that. It's the same, it's the same loop, right? And it's if you believe in, as I do, that that general intelligence is a real thing, um then that, yeah, it's applicable in a lot of different places. The other thing too is that when I was starting out on all of kind of going from being a software guy to, I mean, I did have a pretty low level understanding of how computers work, like all the way down to like even like semiconductor manufacturing stuff that that's relevant to to that, just because that was relevant to the area of software that I was working on for a time. Um, Other than that, I had next to no like exposure to real world engineering,
Hmm.
right? Um, and I had to go accumulate a lot of very painful experience during the period of time between uh, when I started, when I just like crashed out of the software world and crashed into the hardware world. And then like early 2024 came around, and all of a sudden the LLMs got extremely fucking good. And now it's much, much, much more straightforward to upskill. You can, like stuff that like, a lot of times when you're working on an engineering problem in any domain, a lot of times you're looking for bits and pieces of information that are scattered across a bunch of different papers, that once you have them, once you've done that search process, that it all clicks together without a whole lot of additional effort. The LLM can go index that for you and do
Yeah.
that very, very quickly, and pull in all sorts of different things that you then are actually understanding and synthesizing and turning into something useful, often again with the help of the LLM, because we live in an age of miracles. But but there is there's a lot less friction in figuring out
Oh yeah.
exactly what size of heatsink you need for a for a motor, or what exactly what stupid setting some resistor on some IC that you're working with has, that's buried in 800 pages of really badly written
Yeah.
documentation.
Yeah. Good
Like,
luck looking that up on Google 3 years ago.
right, yeah, exactly. Like I spend just as much time looking at data sheets now as I did back then. It's just that almost all of the time spent looking at the data sheets is spent looking at the part of the data sheet I actually need to be looking at, and not digging through and being like, why the hell
Yeah.
did they why the hell is that pin named that? Like,
Yeah.
where in
Yeah.
the world? Wait, they're using 3.5 volts here and not, or sorry, 3.3 volts here and not 5 volts here. Where like I thought the diagram said that was on a completely different rail. That kind of thing. That that sort of like strictly time wasting nonsense is beginning to go away very fast, and I think that
Yeah.
is
Well, and also
that that makes
knowing.
the JavaScript developer to electrical engineer pipeline possible in a way that wasn't the case a few years ago.
Yeah, and knowing what you don't know, I think that's the
Yeah,
most intimidating part is that if you're going into a new domain, you just have no idea how much knowledge you're lacking.
right.
And
Yeah,
the LLM will throw a bunch of stuff at you, and then you're like, okay, I know all of this stuff, but what's all of this over here? And so then you just keep branching basically
yeah,
until you get a high enough level understanding to implement the thing you're trying to do, and then you move forward.
yeah.
Um,
It makes the basic search part of learning many times more efficient, and it makes the execution quite a bit more efficient. Depends on, it's like spiky capabilities, right? Like it depends on, it depends on the area. If you're trying to get, if you're trying to get a an LLM to like write a particularly finicky piece of embedded software, it's still going to require a lot of hand holding to get that right. Um, if you're trying to get an LLM to, to like move some SQL rows around and do a quick regression, they can handle that without you even really looking at it. So, yeah, I don't know. It's not generally true that everyone is now the 10x developer, but there are certainly areas where that is more the case.
you still have to make yourself into the 10x developer. The AI doesn't make you
Yeah.
10x by default, especially when everybody
Well,
has it. And like,
it can make you produce 10x the amount of
yeah,
bad code
yeah.
that you
If you're just measuring amount of tokens, you can
yeah.
produce a lot more slop than ever before, an unprecedented amount of slop code. Uh, I wanted to ask you a little bit about, or take a moment at least to talk about our mutual friend Nick Simmons, who
Yeah.
passed away recently, rather
Yeah.
unexpectedly, um, overnight. I'm not even sure if the cause has been identified yet.
Coroner's
Um,
report hasn't come back yet as of when we're taping this on January 8th.
yeah, but
Yeah.
Nick was a very good friend to me. I didn't
Yeah.
know him for very long. He's a former guest on the show. He came on and talked about Urbit and about Octu Ventures at the time, and has, always been helpful to me very early on when I had, not a lot to really offer him in return.
Yeah.
Cluing me in on stuff, sending me things, inviting me to things, and just all around a really great guy. And you know, you posted about it. I think maybe your post is how I found out about it on
Oh my
X,
God. Yeah.
and then um, you ended up putting in a nice little sort of memorial uh, in your Substack, which I'm also going to link in the show notes, as well as the GoFundMe for his wife and family.
Yeah.
Um, but I just wanted to give you a moment to sort of share, your experience with Nick and your thoughts on that, and we can maybe commiserate on that for a minute.
Yeah. He was a really, really great dude. And yeah, I don't know. I'm still like, I have been, I saw him about a week before, a week before he died. He seemed totally fine. We had our typical interaction initially, where he's about a head taller than everyone who's standing around him, and so he's the first person who sees you and you see as you're walking in somewhere, and immediately huge smile, big wave, Palmer, that kind of thing. Yeah, we had a very we had a good conversation. Had I known that was the last time I was going to see the guy, I don't know, I would have said a lot more. But
Yeah,
yeah, I don't know. 39, way too young, leaving behind, a wife, also mom and dad, and a grandfather, which is just incredibly tragic. Particularly in a family that's like that, long lived. Um, yeah, I I will miss him. Like he was just infectiously positive guy. He, he, yeah, I don't know. I'm bad at this kind of thing, to be entirely
Did
honest.
it's
You
all
know,
right.
I,
Just yeah, yeah.
yeah, and I don't want to, and I don't want to sound like I'm blowing smoke or what have you, like when this kind of thing happens, like sometimes it'll seem like people are like trying to, compete to be like, I was his best bro, all these other things. Um, I guess the main thing I would say was just he was an incredibly good dude, and that story that you described, like your interaction with him, is very similar to my initial interaction with him, where he very proactively tried to include me in a bunch of different in a bunch of different things that that were like personally edifying to me. Like he was always good for an engaging and intelligent conversation about about whatever was on your mind. He was a good sounding board. He cared a lot about building this very idealistic world in which everyone, regardless of how how weird they were, had a place that they could call their own. And he put in an immense amount of work to live those ideals. Like that, yeah. He's yeah. I don't know. He'll be remembered well. He's responsible for way more than I think he was given credit for, or even asked for credit for. Certainly more than he asked for credit for. He's a very humble guy.
Yeah.
He's a load bearing member of the multiple different online communities that I have been part of for years, and the absence can already be felt. Like it just is. Yeah, it's very sad when something happens like that. I don't know. How did you meet him?
Oh, well, I initially met him because Charles Rosenbauer told him to
Indeed.
come on the show.
Yeah.
And so he reached out to me and we did an interview. And then I saw him again I attended Urbit Subassembly in 2024 in
Yeah.
October. And so we met there, and that's when I really talked to him a little bit more. And, I would see him occasionally at different events, things like that. And every single time is same deal, as you
Yeah.
described, just very pleasant, very happy to see you, very enthusiastic about whatever you're doing. Uh, Always had an interesting thing going on. Um, for me, I think it just put that in perspective because uh, he's very close in age to both myself, but also a lot of other people that I know.
Yeah.
And you just don't really think of the time that you have with these people as being so scarce,
Yeah.
as potentially going away. And you just, in my mind, I still don't really think I've totally processed it. Not that we were particularly close or anything, but in the back of my, like, the last thing he did was tell me about send me an invite to Human Directed Futures, right?
Yeah.
And I didn't end up going because whatever, I had other things going on and I couldn't make it to San Francisco. But um, had I known that would have been the last time I had seen him, I probably would have made a lot more effort. So it just, I don't know, it just reminds you that people are not
Yeah.
replaceable, and you just can't take them for granted because you just don't know how long you're going to have.
Yeah. Yeah, yeah, it was very, very sobering and depressing sort of thing. He was highly active guy. He cycled all over the place, like, long distance cycler, hiker, outdoors very often. Spent quite a lot of time moving huge boxes of books around. I think he he might have the most credit at Bay Area used bookstores for turn in stuff of anybody. Someone should go quantify that, because like he might actually have a record there. I do not. I know a lot of book hoarders. Uh, I do not know anybody who did it at that kind of scale, and he had been he'd been doing that for years. Um, yeah, he. I don't know, just like an extremely high vitality individual. And then, yeah, he just laid down for a nap one day and didn't wake up. Like, and no one's really sure why. I don't want to, I don't want to speculate. Like,
Yeah.
we know that it wasn't like carbon monoxide or some other environmental thing. We know that it wasn't, it wasn't. Well, we don't know, but we're fairly certain it wasn't like COVID or anything like that. But yeah, I
Yeah.
don't
So
know. I'm going to be getting an MRI in the early part of this year, in large part because of this. Because just looking at someone who, frankly, is in a lot better shape than I am. Just dropping dead like that is, it's a serious wake up call.
yeah.
Um,
So the GoFundMe for his family and wife
yeah,
is I'm gonna link that in the show notes. It's also linked in your Substack post, and
yeah.
they've almost hit the target of 25K. So
Oh, the target
maybe
was 15K, so they're well over that.
yeah. Well, the new target's 25, but
Good, good.
maybe some people listening can feel the desire to go
Yeah,
pitch in.
if good causes are your thing, his yeah, he yeah, it's I don't know, it's kind of a weird thing. Well, all this is weird and fucked up to talk about. It is an exceptionally expensive thing to go die suddenly young. So, anything that can help his wife and his family out, I think, yeah, uh,
Yeah.
I think they'd be
So
very grateful.
yeah. I just wanted to take a minute to acknowledge that because a lot of people in our sort of overlapping subcultures
Yeah.
gonna know him and know about that.
Yeah, I keep hearing that same story every, like he reached out to me. He was one of the first people to tell me to, like, no, go do the thing, and yeah, since he died, there's been this, a lot of people have been talking, about what they, how they knew him and what they knew of him and what have you, and that story just keeps coming up. I think it's a testament to his, to his character. He was a really good guy.
So what does the future for Matt Palmer look like? The future
Hmm.
of Gen Fab?
Well, we have to grow. Yeah, the interest rate environment. One of the most annoying things about, about running early stage technology companies, is that, you are uh, uh, the price of money does not track what you're working on, how mature it is, or how much money you're even making. The price of money tracks the federal funds rate and what institutional investors are willing to justify into the, high risk part of their spreadsheet. So, we have asked anyone who has been running a company for a while or has been through a couple cycles or what have you, in whatever configuration. There are feast and famine times. We're coming off of a bit of a famine time. Pretty soon, money is beginning to become available for, in large quantity for people working on hardware stuff. The data center boom has been fantastic.
Yeah.
Certainly because, like, it's doing something extremely useful. These artificial intelligence is an extraordinarily high leverage thing. But also because it's teaching American finance how to do capex again, and that has been extremely, extremely helpful. And I think that, for, speaking as someone who's, like, we're going to be the most capex efficient way to spend a dollar on manufacturing in the world. Uh, but you still have to, like, figure out that you need to do that and talk yourself into that, and that is a process. But, like, as the data center stuff plays out further, and as the cost of the cost of supercomputing flops basically starts to limit down to the to the cost of electricity. I think people are going to realize that that there is a whole wider world of places to go apply money, particularly places that benefit directly from rapidly improving deployable intelligent systems, such as automating a substantial fraction of global industry. Uh, so uh, one of the things that is kind of in tension with with the company that I've been working on is that the in when you go like kind of tongue in cheek, but also not, go tell people that you're working on minimum viable von Neumann constructor. The TAM of this, the local group, like
Right, right.
like what is the TAM? Oh, the entire economy. If Elon Musk can do it, I can do it. I can make statements like that too. Like
Sure.
that is also in tension with like how are you going to do like a revenue generating business in the near term. Thankfully we've figured out a couple different angles to that are likely to be one more successful than the other. The electronics manufacturing space is just in dire need of mechanization. You know, we have we have a wide open lane. There are not many people working on this. And all of the people that I am worried about working on this are in China. Certainly qua the United States, we have a very open lane. Um, yeah, this year is going to be about kind of kicking the bugs out of the first like real serious high volume lines that we've ever built. Up until this point, we've been figuring out how to get kind of like lab and workshop scale systems to a price point where we can even attempt the larger scale stuff. We're now as confident as we can be that that we're going to hit a home run on the first try with large scale production systems. So yeah, Fab Zero, in the next few months, then immediately starting on Fab One, which will probably also be Bay Area based. We will look into deploying, particularly once we cross like the full lights out barrier and we have no more people working on, like line of production other than maintenance. We will move to, we'll move to go set up facilities in other parts of the country to serve various different, like quick turn markets. One of the capabilities that we'll have is like for simple boards, if someone's trying to prototype, like a circuit block or what have you. Oftentimes they can do that on a 2-layer or 4-layer board. We will likely have a same day service for that. For certain types of things. The limiter on that is more like component availability. So yeah, that should keep us occupied for most of 2020, 2026 on the kind of like operational, like growing the business end. On the R&D end, just as soon as we have Fab Zero turned on, or really just the first like the first inklings of of some kind of high volume line, we are going to have the ability to do all our motors, all our connectors, every single board that we have in the machines in house. And that is going to unlock not just the ability to go scale the circuit board production processes that we've settled on, but also a bunch of other adjacent things, some of which I can't talk about, but a few of which are teasable at this stage. We are going to be able to make very precise motors and very precise control systems, and do so much, much, much cheaper than is the norm for, like, the stuff you would buy from like Physique Instrumenta, or other other organizations that serve that serve the like precision industry. And there, like I was saying earlier, there are a lot of capabilities, in a lot of manufacturing processes where the primary cost of the output is, is depreciation of the equipment. Um, we are going to probably take a swing at packaging ICs, in addition to doing doing like larger scale circuit boards. So that would be like basically fabricating high density interconnects where with a bunch of different ICs placed directly onto the interconnect, and then you flow a bunch of polymer over that, and then you have you have a system on a chip. We are we're starting to like poke around the edges of what that capability would look like, but it is definitely in the realm of engineering and not science projects. So that's one area that we're really interested in pursuing on the R&D side. That's going to allow us to, and on the other end of that, there are like, there's like products, right? So like, there will be like a, Gen Fab, like SoC for certain applications. So that is something I'm super excited about. There will be a couple novel process technologies in there that, that I find, that have been very neglected. As it turns out, more people should do this, and I know they're not going to, so I'm fine giving away this alpha. Read papers from the 1980s. Just do it. You're going to find some interesting things in there. Particularly, read papers from the 1980s that were published in countries other than the United States or in languages that are other than English.
Like Russian papers?
Nah.
Okay. All right.
So yeah,
Yeah.
that's an interesting area. Another area where we have a structural advantage in reading papers that other people won't read, that are not subject to IP lockdown, and then having the ability to make precision machine tools is this something that's kind of been, not I wouldn't say like white whale is probably overstated, but a thing that I've really wanted to harpoon for a while here, and we just haven't quite figured out the right customer for yet, is really, really, really precise electrochemical machining for relatively large parts. The only way the Russian Air Force is able to stay in the air is that they have all of this like graphite die sink tooling that they use to electrochemically machine, like turbine blisks. So blade disc, like, all is like one single crystal without like thermal deformation and other things like that. We as a society are beginning to find out that we need a lot of turbines. This is particularly well suited for making turbines. If anyone who's in the turbine making business wants to give me a call or slide to my DMs, please do, because I would really, really love to. We've figured out a bunch of little corners of the of the process technology, and we're rapidly gaining in capability around the kinematics that would be required to do that at submicron precision. So that is really cool. That is a program that I cannot justify for my own purposes necessarily quite yet, but if anyone else wants to go, wants us to go make that for them, we would be more than happy to. Yeah, gosh, what else can I talk about? There is a, yeah, the circuit board production process that we have decided to run with is substrate agnostic. So if anyone has any need for particularly large flexibles or for ceramic PCBs for power assemblies, that is a capability that we will have most likely right out of the gate. More a question of like sourcing those substrates reliably than a question of whether or not we can pattern on them. Um, uh,
I'm gonna
yeah,
ask you to get a little bit fantastical here.
sure.
Um, so what is the like most idealistic 10,000 foot vision for Gen Fab? If I just let my imagination run wild and say, where is Gen Fab in 20 years, 50 years?
The
What does it look
moon,
like?
the
The
moon,
moon. Yeah, yeah.
the moon. No,
Factories on the
terrestrially,
moon.
let's assume that we don't move all industry to orbit.
Yeah.
Which is, yeah, I don't know. That's a discussion to be had. Um, yeah, we at like 5 years out from today, maybe even 3 or 4 years out from today, I would like to be shopping for trailing edge semiconductor production equipment. Um, a year or so after that, I would like to be making a bunch of ICs. I would like to be expanding into sensors and into there are a lot of interesting things. Not to get too esoteric here, but there are a lot of interesting things that you can do with RF generators at very small scale, and there's a lot of interesting like micro and nano fabrication stuff that has again, people should read old papers, and then recalibrate what they think is possible with the technology that we have today. Um, yeah, we having a semiconductor capability in house, like 3 to 5 years out, having precision machining at very large scale in house, three like 2 to 3 years out, advancing down those tech trees then very aggressively, then about 10 years out, probably the only external thing that we'll be buying will be raw materials and logic ICs. Um, the that that is a an ambitious technical path, but I also think that it is total. I can justify every part of that at a pretty deep level. The big question in there is like how we, how do it isn't so much how we climb that tree, because that is part of what I've spent the last several years figuring out. It's what we do commercially at each of those stages, and I think somewhere in there we're going to become a very, very large electronics contract manufacturer that is making an increasing fraction of the component level inputs for for initially high end devices, and then once we get our capital costs low enough for all sorts of things, and at some point we'll flip over into a regime where we're going to be able to do volume better than everybody else, and I think that'll be our first like really big business model shift while we're underway. Once we get into like the 80% internal production range, we can kind of start, like every dollar we raise goes that much further. Um, and we can kind of start stamping out facilities. That's the point where it's going to go from like, a couple large facilities, in various different parts of the country and in other places in the world to just blitz scaling. And that is the point where, I want to be going to every large electronics design house in the country, like Apple ideally, and providing them turnkey large scale production of whatever they need. Um, yeah, that I think is all, that is the like 5+ year plan, is to, is to get to the point where we can make a very large fraction of the equipment that we need, such that we have a obvious pencilable, financial math advantage over everybody else doing this kind of thing. And then just lean into that as hard as possible. Maybe it's as a public company, maybe we do the Stripe thing and we're private for a long time. Um, I think that there's no way to hack this without some leverage. So I think that we may structure our business such that it is very bankable. Like credit financing, and tap into private credit. I think that we have taken millions of dollars in VC capital. We'll take millions more in VC capital. I you know I there is a point at which that system is saturated, um, and you need to start going to different entities. I think that one of the big problems AI is running into right now is that they thought they could take they thought they could get all the way to artificial superintelligence with like Andreessen bucks, and it turns
Right.
out that you need Saudi Arabia bucks
Yeah.
to even get to Opus 4.5. So there was a little bit of a misfire there, I think, from like a business construction perspective. Um, the way that we're going to be, I think, a lot more willing to look at interesting financial structures relatively early on. Probably post like what in startup world would be like traditionally like a series B or C.
Mhm.
That's when we'll likely start to look at like credit financing. The DigitalOcean did this actually. So like a lot of DigitalOcean's infrastructure is actually bank financed, and they did a very good job of making it clear to their creditors that they can just throw the infrastructure in and then print money on it. Once we're able to unambiguously make that case with high volume production lines, I think we're gonna do the same. Um, as we get into the 10+ year range, uh, yeah, global manufacturing powerhouse of record, like that is the objective. um there are a lot of things that could go wrong along the way. I'm not going to promise that we're going to execute perfectly at every stage of this, though we've done a pretty good job of staying alive and developing our highly differentiated way of doing things so far. Uh but yeah, like problems start to crop up when you start to hit inflection points. So,
Yeah.
you know, we like looking, and these are all the this is all the like no forward looking statements, da 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 da, stay on the right side of Reg D type of stuff, that like little benediction that I need to do whenever I talk about this stuff. So bear with me. But once we get into into like the 10+ year range, that's when it becomes harder to see what exactly it is we're doing and what exactly the business model is at that point. For comparators, like look at BYD, for example. They started with batteries. They now do electric cars. Not many people know this, but they are also a huge contract manufacturer. Like they make a substantial fraction of all MacBooks, Mac Minis, iPhones, and so on. Um, you know, uh, they, I don't think, started out thinking they were going to go make electric cars. They did know that they were going to be a contract manufacturer, but at some point they realized, oh, we have a productization division that we could build here that could be intensely lucrative. and then they went and did that. And now that's like, I think like 2/3 of their business or something. Like that kind of adaptability is extremely important to cultivate. We will probably get into our first, like, this initially started as a product company.
Mm.
Our idea was that, we were going to go outfit other people's factories with, lots of machine tools. And it turns out that the one, that American manufacturing is in an extremely bad state. And, the parts farms are the one thing people are bad at, or are worse at than operating and stuff like that, is capitalizing more of it. So if we have this distinct capex advantage, then there's no reason for us not to, exploit that internally. So that puts us kind of in, more of the manufacturing services business, for the initial scaling phase. But once we're through that and we've got both feet planted and we're growing fast, that's when productization starts to come in again. So I mentioned briefly earlier, the bamboo killer, that's a thing we've been throwing around. It's a product that we know we can make world class, something absolutely world class with zero additional engineering effort. Robot arms, all sorts of lab automation stuff. One thing that we are a self-reproducing factory company. We are not a like bio lab company, but if a biotech company wants me to go build a fully automated lab for them, I will look really closely at that. If Anduril wants us to go build, lines to go make missiles, we'll look really closely at that. I wouldn't go build a manufacturing line for another factory. That's probably not, the best competitive positioning for the future. But there are a lot of other companies who have objectives that we could align to.
Yeah.
So that is one configuration of the business. We could also become a, like Texas Instruments has a lot of this like highly durable IP, right? Because they make a lot of, essential systems that, that don't change that much, that they can just pump out more of at any time. We're going to have a system that, like we'll accumulate the capital equipment in a very different way to them, but we'll have a system that in the terminal state looks a lot like that. You'll have a lot of fully depreciated capital equipment and a lot of IP that you developed in order to get there. So, there are things that need to go into any industrial facility or any piece of electronics that can be packaged. That will probably include like power supplies, for a small piece of electronics. That'll include power supplies. That'll include, little like SOCs that do things in addition to just like raw processor compute. I would love to get into the displays and sensors games, though that would be very, very cool. I would really love to make a radar product, like a very so it turns out all like if you can make it the PCB, you can also make like a little phased array on that PCB. So I would very much like to be in the in the sensors business too. So yeah, like packaged products like that is another direction we might go.
I have visions of
Yeah,
dark factories running 24 hours a day, spread all over the United States.
all over the world,
That's what's dancing in my head, at least.
hopefully. Yeah. Yeah, we are still in the most embryonic of stages for this. As far as we've come, we still have a hell of a long ways to go. And I am properly obsessed with this problem, and I've sunk my teeth into it, and it's going to take a lot for me to get dragged away from it. Um, I and I think that it is it's a deeply consequential thing to be working on, but it's also like the economic potential is freaking enormous. Like if uh if we pull this off, we're going to be one of the biggest companies in the world, and that that is a strong motivator. Like, what you can do at that scale, that becomes very interesting. Like, being able to go sit down at the nation state table and contribute,
Yeah.
on behalf of the Anglophone thalassocracy, et cetera, et cetera. We're all patriots here. But that is, like the potential for that down the road is very motivating.
All right. Well, Matt Parlmer, General
Great talking.
Fabrication. Thanks for coming on the show. I really appreciate it.
Yeah, likewise. Thank you for having me.
All right. See ya.